You are welcome to this lesson. My name is Tr.Katimbo Richard, teaching mathematics. In the last session, I introduced a topic known as time. As you know, time management is very important as far as one's life is concerned. Today, we are continuing with the same, that is time, but annexed with distance and speed. So, today we are looking at speed, distance, and time, all combined to see how practical they can be. Today, I've come with comprehension questions which pose a lot of challenges to the learners. Therefore, I urge you to follow strictly, step by step. Thus, when you will gain something from this lesson. The example today that begins the day reads, Betty and Richard left Kampala at 8 a.m. for a 360-kilometer journey to Gulu. Betty and Richard left Kampala at 8 a.m. for a 360-kilometer journey to Gulu. Betty was driving at a speed of 60 kilometers per hour, while Richard was driving at a speed of 90 kilometers per hour. The question reads, how far from Gulu was Betty when Richard arrived there? It should be noted that when one drives at a higher speed compared to the other, much as they are obliged to completion of the same journey, that is, in this regard, 360 kilometers, that very person driving at a higher speed reaches earlier. So, the higher the speed, the less time taken. And the lower the speed, the more time taken to do the same journey. In this case, the same journey of 360 kilometers. Therefore, much as they are going to start at the same time, that is Betty and one Richard, heading for Gulu, that is from Kampala, doing a 360 kilometer journey. Richard, who drives at a higher speed, will reach earlier than Betty, who drives at 60 kilometers per hour compared to the said Richard that moves at 90 kilometers per hour. Now, we are going to see the distance or the difference in distances when that Richard arrives there earlier than the said Betty. So, first this question, you start by getting the time taken by each of them and then compare in terms of difference. So we shall start or begin with Richard that moves at higher speed. Thus you say, time taken by Richard. We know time equals distance divided by speed, which distance is 360 kilometers, and speed for the said Richard, which is 90 kilometers per hour. So bring it down here and say 360 kilometers divided by 90 kilometers per hour. Now, cancel off the kilometers for the lookalike here. Kilometers off, remain with hour, so that the time will be hours. Now, we divide by 10 by 10, then 9 divided by 9 is once, and 36 divided by 9 is 4. Thereby taking 4 hours for the entire journey of 360 kilometers. Then you resort to working out the time taken by Betty, states in the same way that time is equal to distance divided by speed. Continue and say time equals the whole 360 kilometers divided by Betty's speed, which is 60 kilometers per hour, still cancel off the hours, hour, and then by 10 by 10, and then cancel or divide by 6. 6 divided by 6 is 1, and 36 divided by 6 is 6 hours. So Betty will cover that whole journey, or entire journey, in 6 hours. Why is it so? She was driving at a less speed compared to Richard. So as Richard takes 4 hours, Betty will take 6 hours to complete the same journey of 360 kilometers. Now, you will proceed on to getting the difference in time taken between these two. You get 6 hours minus 4 hours, thereby getting a difference of 2 hours. Then, find the distance. The person will still be moving, that is Betty, will cover when Richard arrives there in 4 hours. So, the fact being that Betty was driving at 60 kilometers per hour, so in distance finding, we are going to use her speed and the time difference here, which she will have to take when Richard has already arrived in Gulu. So we say distance equals speed times time. Distance is equal to 60 kilometers out of hour times 2 hours. Then divide the hours of hour. So 60 kilometers times 2, you will get a distance of 120 kilometers. Remember the question, how far from Gulu was Betty when Richard arrived there? You say therefore Betty was 120 kilometers from Gulu when Richard arrived there. In that way, you have answered the examiner's question. Then example number 2 today reads, 2 buses A and B start a journey at the same time moving towards each other. 2 buses A and B start a journey at the same time moving towards each other. Bus A moves at a speed of 40 kilometers per hour, while bus B moves at a speed of 60 kilometers per hour. Now the question, if bus A starts at town P and bus B at town Q, a distance of 240 kilometers, after how many kilometers from Q will they meet? After how many kilometers from Q will they meet? It should be noted that in the first example, we looked at one-way traffic when both buses, both people, that is Betty and Richard, we were moving towards Gulu. Whereas here, it's two-way. One starts from P and another one starts from Q. So we've got 2 buses A and B. A moves at a speed of 40 kilometers per hour, while bus B moves at a speed of 60 kilometers per hour. You will see that bus A starts from P, whereas bus B starts from Q to do the same journey. Now, this one, you need to know, as one starts from the other side, that's from Q, another one starts from P. They will meet. The meeting point will be the entire 240 kilometer journey done. Why? One will come from Q, another one will come from P, and they meet. So the journey done by B added to the journey done by A at the meeting point will make the entire journey of the whole journey. That is what is going to be done here. Now, you are going to look at this question and start applying. It should be noted that 60 kilometers per hour means 60 kilometers done every hour. The word per means each, means every, or for a single. So 60 kilometers are done every hour by bus B, as 40 kilometers are done every hour for bus A. Therefore, start by applying this style. You say, bus A covers a distance of 40 kilometers in 1 hour, whereas bus B covers a distance of 60 kilometers in 1 hour. This is derived from the speed at which they are actually driven. Then, since they are doing a duty of covering a journey, so the combined effort will bring a statement that reads, buses A and B cover 40 plus 60 kilometers in 1 hour. And so, buses A and B cover 100 kilometers in 1 hour. Therefore, if they were to combine their speed, they would be moving at a speed of 100 kilometers per hour. Now, you will state that time they will take to meet. Time they will take to meet. So you're going to use a combined speed here of 100 kilometers per hour to find the time they will take to meet. So you say, as you know, time is equal to distance divided by speed. Time equals 240 kilometers divided by 100 kilometers per hour. Remember, they are doing a journey of 240 kilometers between town P and Q. So you get 240 kilometers divided by the combined speed, which is 100 kilometers per hour. Cancel off the kilometers, like you see. Then by 10, that's division. Then divide very well. So 10 divided by 10 is a 1. Then 24 divided by 10 is 2. Remainder 4, which means time is 2 and 4 out of 10. Which 4 out of 10 is reducible by 2. 4 divided by 2 is a 2, and 5 divided by 2, 10 divided by 2 is a 5. Hence, they will take 2 and 2/5 hours to meet. Now, the question is, after how many kilometers from Q will they meet? Now look at which bus was being driven from Q. That is bus B. Bus B was starting at Q, or from Q, and which bus B was being driven at a speed of 60 kilometers per hour. So now we are going to get distance from Q using bus B speed, or the speed at which bus B was being driven. Thus, you say distance is equal to speed times time. Distance equals 60 kilometers out of hour times the 2 and 2/5 hours they will take to meet. Then convert 2 and 2/5 mixed fraction to an improper by multiplying the denominator by a whole number plus the numerator out of the denominator. So hence you say 5 times 2 is a 10 plus 2. That's why I've got a 12 out of 5. Now, we've got 60 kilometers times 12 out of 5, having cancelled off the hours, so the distance remains to be measured in kilometers. Now, we are going to divide by 5. Remember, in multiplication of fractions, you are only allowed to divide in this regard if you have only that multiplication. So, we go by 5 once, then by 5, 1 remainder 1, 10 by 5 get 2. Hence, remaining 12 kilometers times 12, and 12 times 12, you get 144 kilometers. Therefore, after 144 kilometers from Q, these two buses will meet. Then we shall look at part B of number 2. The question reads, if both vehicles start at 9 a.m., at what time will the two buses meet? Question B reads, if both vehicles start at 9 a.m., at what time will the two buses meet? Since we have found out that they will take 2 and 2/5 hours, you start by saying time taken to meet. You transfer it from A, which is 2 and 2/5 hours. And now, we've got 9 a.m. It should be noted that 9 has got the hour section and the minute section, whereas time taken has been given in hours. Therefore, you convert the fraction hours to minutes, maintaining the whole number, that is 2, constant. So it's widely known that 1 hour is equal to 60 minutes. What about 2/5 hours? We've got 2 out of 5, or 2/5 times 60, and then divide by 5 once, by 5 get 12, you remain with 2 times 12 minutes, which 2 times 12 minutes 24 minutes. So 2/5 hours are equivalent to 24 minutes. So they will meet after 2 hours and 24 minutes. Now you say the 2 buses will meet at, you get 9 a.m. the start of the journey plus how long they take to meet, that's 2 hours 24 minutes. Then you go down to add here, you say 900 plus 2, 24. You add 0 plus 4, 4. 0 plus 2 is a 2. 9 plus 2, get 11. So they will meet at 11:24 a.m. It's a bit challenging, but you need to watch it over and over to understand it better. We shall then look at 3. Example number 3 today. Someone is called Rita. So Rita left Kotido at 8 a.m. to go to Masaka, 120 kilometers away, driving an average speed of 40 kilometers per hour. Reading, Rita left Kotido at 8 a.m. to go to Masaka, 120 kilometers away, driving an average speed of 40 kilometers per hour. Then what happened? At 8:30 a.m., her vehicle got a puncture and she had to wait for 30 minutes while mending that puncture. The question is, find the speed she had to drive at in order to reach Masaka town at 11 a.m. Now, this question creates some responsibility within a person. This person has got an appointment at Masaka at 11 a.m. But you know, you cannot make an appointment with problems. On the way, there was a problem of a puncture. Good enough, it was mended as soon as possible. That is in 30 minutes. But much as that is so, this Rita had to go and reach the said Masaka town at 11 a.m. Now, is seeking for your advice. That is, which speed must she later drive at to meet that appointment? That time, she must reach Masaka town. So, this is the way one handles a situation that is brought like this. You start by saying, distance covered by the said Rita before the puncture. We know that distance is equal to speed times time. We have the speed at which she was driving before the puncture, which is 40 kilometers per hour. But I don't have the time, but we were fortunate enough to know when she started and when the puncture actually occurred. So she started the journey at 8 a.m. and the puncture actually occurred at 8:30 a.m. Therefore, you say time taken, but time taken is equal to arrival time, that is at the place where the puncture occurred, minus when she started the journey, that's departure time from Kotido. Therefore, you get 8:30 a.m. minus 8:30. You subtract very well, and 0 minus 0 is a 0. 3 minus 0, you get a 3. 8 minus 8, you get a 0. It's so much advisable when you are subtracting to have these AMs off so that you get the answer in minutes and hours. So the difference has been realized in only means, therefore, that person had only driven, that is Rita, had only driven for 30 minutes when she got a puncture. And because the speed has been given kilometers per hour, we must have kilometers, which you have already. That's 120 kilometers, as well as time in hours. Now, we have got a difference here in minutes, which necessitates converting to minutes before anything is done. You state that 60 minutes are equal to 1 hour, then 30 minutes is equal to 30 out of 60 hours. That one makes a half an hour after third division. So this person, that is Rita, had driven for a half an hour when she got a puncture. It's the one we are going to use to find the distance she had covered before the puncture. using the speed at which she was driving before the puncture did happen. So I've got 40 kilometers out of hour times a half an hour. So you will then divide, since you have sensed multiplication of a fraction. We say 2 divided by 2 is a 1, and 40 divided by 2, you get a 20. Cancel off the hour and hour to remain with the 20 kilometer distance covered before the puncture. Since we have the distance covered before the puncture, and we have known that it was a 120 kilometer journey from Katimbo to that is the town was going to, that is Masaka, you get the remaining distance. The whole journey, that's the entire journey of 120 kilometers minus already covered, which is 20 kilometer journey to get 100 kilometer journey to be actually driven to reach Masaka. And now to be covered to reach Masaka. Now, remember, we have to advise this person in terms of speed, which speed is got by having the remaining distance as well as the remaining time. Now, the remaining distance has been ascertained as 100 kilometers, so must we go to the time section. Now, this person got a puncture at 8:30 a.m. and the mending of the puncture took 30 minutes. Thus, you write continuation time. That is when did she leave that place where she got a puncture. You get 8:30 a.m. plus 30 minutes, and now you say 8.30 plus 0.30. You know 30 plus 30, you get 60. You cannot say 60 minutes past the hour, so you have to divide 60 by 60 and get 1 remainder 0. So, meaning 1 hour and no minute. Therefore, under means, you write 00 and then regroup the one you call carry 1 hour onto the hour section. So, I've got 1 plus 8 plus 0, thereby getting 9. So that person continued with her journey, that is Rita, at 9 a.m. Now, her intention is to reach Masaka town at 11 a.m. Now, she has resumed the journey again at 9 a.m. So, get the remaining time by subtracting. That is 9 a.m. from 11 a.m. Hence, right, 11 a.m. minus 9 a.m. Now, leave the a.m.s here, deliberately in subtraction. Write 11.00 minus 9.00. Under means everyone can see. We don't have any remainder, so I've got 11 minus 9, which is got 2. So, this person is remaining only 2 hours, that's Rita, to reach the appointed time of 11 a.m. And remember, the remaining distance was ascertained as 100 kilometers, and now the remaining time is 2 hours. They are the ones you are going to use to advise this Rita on the speed at which she must drive. So you say she must drive at, now find the speed. Speed is equal to distance divided by time, which remaining distance 100 kilometers and remaining time to reach the Masaka town is 2 hours. Then divide by 2 once, divide by 2 5, and 0 divided by 2 is 0. She then must drive at a speed of 50 kilometers per hour to reach Masaka town at 11 a.m. That's why conclude and say, therefore, Rita had to drive at 50 kilometers per hour in order to reach Masaka town at 11 a.m. So those are challenging numbers, or some of the challenging numbers concerning speed, distance, and time. So what you need to know, you need to comprehend. That's reading and understanding the situation that is at your disposal. Then you will tackle it accordingly. I am teacher Katimbo Richard, that has helped you know what you didn't know, that is if you didn't. Thank you for viewing. Stay safe.